So for the first one is pretty okay, because now remember in secondary school what you learn is the fundamental theorem of algebra, meaning if the polynomial equation of degree of n, you have n roots. That is very important. So if it's a quadratic equation, you expect to have 2 roots. If linear equation, you expect to have 1 root because it's degree of 1. And if it's power of 3, you expect to have 3 roots and so on. Okay. But then you learn conjugate roots theorem. Conjugate roots theorem say that if all the coefficients are real, the complex roots will exist in pairs. So 2, 0, 2, 0, 2, 0, 2. So you combine these two logics together. For cubic equation, it is only sensible to have either your roots are all real, or one pair of complex conjugate pairs and 1 real. Okay, you can never have three fake roots, 3 imaginary roots, because this has to come out in pairs, and you need to have 3 roots. Okay, so what does it tell you? It tells you it makes sense. Actually, it have to make sense with you. So if you think about the power of 3 roots, right? The cubic graph, it looks like that. Okay, cubic graphs looks like that or like that, right? It no matter how you draw it, right, it will definitely cut the x-axis one. It definitely have 1 real root one. This is 1 real root, right? This is 1 real root, right? If you draw this is 3 real roots, right? 3 real. There's no other way you can draw your cubic curve that it doesn't cut the x-axis. That is what it's trying to say. So cubic curve, this tells you that it definitely cuts the x-axis. If you want to really expound on it, you want to understand it, it means that you have to have 1 real root. No matter how you draw the cubic curve, right, you will always cut the x-axis. Okay, so they may ask you, explain why this equation will always cut the x-axis. You can just, it's the same explanation. So since this is what you write, I'm just going to type because it's faster. Since equation has all the coefficients are real, equation have more than two non-real roots. Complex roots will exist in conjugate pairs by conjugate roots theorem. Okay. Equation has a degree of 3. Thus, it will have 3 roots. Okay. You don't need to write the fundamental theorem of algebra in. You don't even need to write the complex. But I'll just write it down. Thus. Okay. Hence, cannot have more than two non-real roots. Cannot have more than 2 non-real roots. Hence, yeah, that's it. It can only have a maximum of 2 non-real roots. Yeah, so I write it. Okay.